built-up section. So built-up section for a compression members become efficient due to the fact that the slenderness ratio of the composite section can be made equal in both directions. For example, if we have a channel section, so in that case the Rx value will be sufficiently large than that of Ry value. So if the effective length in both the direction is same, so the slenderness ratio Rx will be less than that of Ry. So if we want to equalize the slenderness ratio about both the axes x and y, so we can use a built-up section. So if we use a built-up section like this, so in that case we can also increase the value of Ry. So in case of built-up section, the value of Ry can be adjusted or can be increased than that of the individual member. And finally we can get a section which has equal slenderness ratio about both the axes. When the slenderness ratio of the member or the section is same about both the axes, so in that case our member will have equal strength about x and y axis. So this will economize our section. The spacing between the individual element may be varied to get the desired radius of gyration. So we can get our desired radius of gyration Ry by adjusting the spacing between the members. For example, if we are using this W section to make a built-up section, so in that case the distance between their webs can be 1.5d to 1.6d to equalize Rx and Ry. And if we are using channel section back to back, so in that case their distance between their webs should be 0.6d to 0.7d, and d is the depth of the section. And if we are using this channel section to make a box section or to make a built-up section by arranging them by face to face, so in that case the overall width should be equal to 0.9d to d. So in that case we can get a section with a radius of gyration about y-axis and radius of gyration about x-axis with almost same value. While making a built-up section, we use lacing elements or tie plates to connect these members or the members of the built-up section. We use lacing element or tie plates or battens. The purpose of lacing bar is to make the entire component act as a single unit. So to connect these channel sections so that they can act as a single unit, we use lacings. When the structural member is consisting of two or more shapes and cover plates are not provided, then we use the lacing. Either we can use lacing, we can use tie plates, we can use battens, or we can use perforated cover plates. So if cover plates are not used, or battens as well as tie plates are not used, so in that case we will prefer lacings. The next is what are the benefits or the function of lacing. So they provide resistance against the shear force developed by bending produced due to buckling or due to simultaneous action of bending moment. So if the column is subjected to bending because of the lateral load or the bending moment or because of the buckling, so in that case shear forces will develop. So these lacing element will resist those shear forces. The second function of the lacing is to decrease the effective length of individual components. So in case of built-up section, we have, for example, these components, these angle sections. So when we make a built-up section, the length of individual member will be sufficiently large. If we consider individual member, their slenderness ratio may exceed the limiting value of 200. So in that case, to limit this slenderness ratio of the individual member, so we need to use lacing elements or we need to use tie plates so that the unsupported length between the lacing points or the slenderness ratio of the individual section between these lacing points should be less than this limiting value 200. The third benefit or the function of this lacing is to hold the various parts parallel and at correct distance. So to keep these parts at the correct distance apart from each other, we need this lacing. Otherwise, the next function is to equalize the stress distribution between the various parts. So for example, we have a box section made up of angles, built-up section made up of angles, and if the load is acting near to this corner, so in that case this section or this angle will be stressed more than that of the other members or other channel section of the built-up member. So in that case, If we don't use the lacing element or tie plates, this member will be continuously stressed with the larger value and the other member will remain unstressed or they will be under stress. So when we use these lacing elements, so what they do, so if the stress is more in this member, so this stress will be transferred to the second member with the help of this lacing. So similarly, at the later stages, the stress will be transferred from this member or this element to the other elements because of the lacings. Fifth benefit is to allow wind to pass through, reducing the wind pressure. So if we use perforated plate or cover plate, so it will cover this whole face, and in that case there will be a huge wind pressure. But when we use lacing, so there will be empty space between the lacing elements, so wind can pass through that empty spaces and the wind pressure will be reduced. So here we have one note that area of lacing is not included in the composite area of the section. For example, we have the built-up section and we have lacings over here. So when we calculate the area of this built-up section, we don't consider the area of these lacings, as it is not continuously present throughout the length. Because it is not present throughout the length, it is at intermittent stages, so we do not consider the area of lacing. But in case of cover plates, which is present continuously throughout the length of the member, so in that case we can consider the area of cover plates to calculate the total area of the section, total area of built-up section.